In section 8.2, we're going to problem solve with proportions. Let's look at this first example. Candy bars are on sale for $1.50. How much will 6 candy bars cost? Well, there's multiple ways to get this answer. In fact, I'm guessing many of you can just figure this problem out and get the correct answer. But I want you to focus on solving this problem with a proportion. I want you to concentrate on setting the problem up correctly and then getting the answer later. In order to focus on writing this problem with correct proportions, we need to first pick our variables. In this case, we're going to only have one variable. I'm going to call that variable x, and x is going to be the cost of, and I don't want to just say cost of candy bars. I want to say it's going to be the cost of 6 candy bars. That is my unknown, my variable for this problem. In other problems, I will have more than one variable, but in this case, I just have one variable. Step 2. Set up a consistent proportion. Consistent means left and right, top and bottom are the same. They're consistent. I'm going to use a proportion, so I'm going to have a fraction equaling a fraction. Now when I talk about left and right, I mean left side of the equal sign, right side of the equal sign. When I talk about top and bottom, I'm talking about numerators and denominators. One of the ways I can set up a consistent proportion is by saying 4 candy bars relates to $1.50 as 6 candy bars relates to X. I can tell that this proportion is consistent because my tops are the same, my numerators are the same, bars and bars, and my denominators are the same, money, money. This isn't the only way to set up a consistent proportion. If I say X over 6 bars equals $1.50 over 4 bars, I've also set up a consistent proportion. Cost to cost, bars to bars, left and right, top and bottom. I could also compare bars to bars and cost to cost. If I say 4 bars relates to 6 bars as $1.50 relates to X. Top and bottom, bars and bars. Top and bottom, cost and cost. And if I look, 4 bars is consistent with $1.50. 6 bars is consistent with X. What I want to try to avoid is a proportion that looks like this. 6 bars to $1.50 equals 4 bars to X. Bars and bars are both on the top, cost and cost are both on the bottom, but 6 bars doesn't match up with $1.50 and 4 bars doesn't match up with X. So a proportion like this is inconsistent. I could keep going. In fact, there are 24 different ways that I could set up proportions. 12 of those proportions would be consistent, and 12 of those proportions would be inconsistent. So I need to make sure that I pick a proportion that is consistent. Step 3. After I've picked a consistent proportion, I need to solve for my variable. In some cases, there will be more than one variable. In this case, there's just one variable. If I have more than one variable, I'm going to have to come up with a second proportion. I'm just going to pick this first proportion. I could have picked any of these three consistent proportions. I'll get the same answer in all of them. To solve for x, I need to cross multiply. I'm going to drop my equal sign down, and I'm going to take numerator times denominator. So I'm going to have 4 bars times x equals $1.50 times 6 bars. I can multiply 1.5 times 6, and I end up with $9. Now I wrote that kind of weird because I still have my dollar sign and I still have my bars. Now I need to solve for this x by dividing by 4 bars. 4 bars divided by 4 bars is 1. 1 times x is just x. And on the right side, this is a little bit like a science problem, where I have units in the numerator and units in the denominator. And since I have units in the numerator and the denominator, the bars will cancel, and I'm left with just dollars. So my answer is 9/4 dollars. But that answer seems kind of weird because we would never say 9/4 dollars. Instead, I want to convert 9/4 to a decimal. A good rule of thumb is if the problem starts with a decimal is okay in the answer. Or if I'm working with a problem with money, decimals are okay. Otherwise, I want my answer to be a fraction. In this case, I had decimals in my problem to begin with, and I'm working with money, so I need to convert 9/4 to a decimal. 4 goes into 9 2 times, and I'm left with 1 remainder. So I'm left with 1/4. 1/4 as a decimal is 0.25. In a problem like this, the answer is important, but the most important part is really setting up the proportion correctly and consistently.